Our data are gathered from a number of sources. Drill cuttings are usually examined, tested, and logged early in the development of a field to determine rock type and texture. Coring, which gives us large, coherent samples of the reservoir for analysis, is especially crucial to reservoir characterization. Usually, the geologist relies most heavily on data obtained from well logs. Generally, a number of different logs are run in a well and correlated against each other. Each log is a chart of how the various rock layers respond to an induced signal or produce natural signals of their own. Because each log reflects a different physical characteristic of rock, it can be used to help calculate or infer petrophysical properties of central importance to reservoir studies.
Let's just take a minute to see how geologists, using a limited amount of log data, not only infer a depositional environment, but predict reservoir geometry as well. Let's say that well cuttings have shown our formation to be a well-sorted, oil-bearing sandstone. The gamma ray log shows the upward coarsening profile typical of a bar sand in a fringing delta environment. Comparing the dip meter log, we see a pattern of increasing dips in the shale just above the bar. These likely represent draping of the softer shale over the flanks of the bar, as shown here. This then gives us two crucial pieces of information. One, the direction of the bar's long axis, which is roughly 90 degrees to the draping, and two, the thickest part of the bar, which is to the southeast. Thus, the basic geometry of this potential reservoir can be quickly sketched from data of a single well. But we also have to remember that log data is not always clear, and information from cuttings and cores must be used for reliable interpretations of depositional environments.
Cores, in fact, are usually the true backbone to any reservoir study because they provide samples for both visual analysis and laboratory testing. After it's recovered, the core is usually cut along its length to expose a fresh surface, which is then inspected and described in detail by a geologist. Most cores are divided into vertical sequence of genetic units on the basis of internally consistent features such as these that show a common depositional origin. Some of these features are relatively small scale and therefore need to be studied carefully. For example, a geologist has to describe in detail such properties as grain size, texture, and mineralogy. Special attention must be paid to sedimentary structures, such as crossbedding, since these are direct indicators of specific depositional processes and possible reservoir quality trends. Also important are fossils and other signs of biological activity, such as burrows, which can be used to distinguish specific sub-environments and thus facies.